Welcome to Homework Help for Worksheet 1.5. This is Dr. Eddie Morgan at Clovis East High School. Remember that each one of these problems in the homework help corresponds to a problem on your homework. And so for any problem that you're struggling with, look at the corresponding problem, watch how we work it, and you should be able to figure out how to work the homework help. So let's get started. Today we're looking at conversions, and we want to convert 5 foot 4 inches and say how many inches that is. First thing to notice is that another way to write this is actually 5 feet plus 4 inches. Okay, so what we need to do is change the 5 feet to 4 inches. Now we use what's called conversion rates, and I like to describe them as two numbers that are equal to each other. So I draw this funny little 1 here, and in one sense I'm going to compare feet to inches, and I know that there are 12 inches to 1 foot. Okay, and so as I come here to my 5 foot, I'm going to deal with the 5 foot first, and so I'm going to multiply it by a conversion rate. By the way, I could also have written that as 1 foot to 12 inches. All right, so what I want here is I want to end up with something that has inches in it. So as I look here, I have a feet here. So I want to get inches, so I want my inches here, and I want the feet, if you can imagine dividing the feet out to go away, I end it with inches. So which conversion am I going to use here then? And the answer is I want the inches on top, so I want 12 inches to 1 foot. And so in this way then, 5 times 12 is 60 inches. Okay? So now I'm going to plug that back into here, and now I have 60 inches plus 4 inches. So my final answer is 64 inches. So the answer there is 64 inches. So 5 foot 4 inches is 60 inches. You may notice, you may say, oh, there's 12 inches in a foot, so 5 times 12 is 60 plus 4. But on more complicated ones, you may need to remember these conversion rates and know. You usually know you're either going to be multiplying by 12 or dividing by 12, but you want to make sure you do which one is right. In this problem, we're going to go from kilograms to pounds, so we need to know our conversion rates. Two ways to look at this. I can look at it, I'm going to compare them, I'm going to make my little comparison here, 1, and I know that 2.205 pounds equals 1 kilogram, or I want to do it this way. I also know that 0.454 kilograms equals 1 pound. So there's two ways of doing that, and depending on whether you want the pound in the numerator or the denominator. Now I just looked those up. I just Googled those. That's where I found them. You may find them in your book. So I'm looking here at 2.5 kilogram, and I'm going to set this up. I need to multiply by one of these conversion rates, and I want to end up over here with pounds. Okay, so I want to get rid of the kilograms, so that means I'm going to have something with kilograms in the bottom, so they divide out, and I want to end up with pounds here. So you can look over here and see which conversion rate do I want, and it's obviously the first one. So I'm going to have 2.205 times 1, and now we'll get out our calculator here, and 2.5 times 2.205 equals, and I get 5.5125. Let's round off to the nearest tenth, and so this is going to be about, notice that's less than 5, it's going to be about 5.5 pounds. So I'm going to put this at 5.5 pounds as my answer. Okay. In the next step, we want to go from hours to minutes. Now this one we should be pretty clear on. We know our conversion rates is either going to be 1 hour is the same as 60 minutes, or we're going to say 60 minutes is 1 hour. Okay? So in this case here, I'm looking at 3.5 hours, and I'm going to multiply it by one of these conversion rates, and I want to end up with minutes. Well, since I want to end up with minutes, minutes needs to be in my numerator, And to get rid of the hours, I'll divide by the hours. So I want minutes per hour, and that's going to be here. So 60 by 1. So all I have to do is multiply 3.5 times 60. And I get 210 minutes. Now you see, some of these you're more familiar with, and you could have just thought in your mind, oh, 3.5 hours, each hour is 60, so 3.5 times 60. But remember, sometimes you just take to make sure, because you know in this case you're either going to be multiplying by 60 or dividing by 60. Our next problem is a little more complicated because we're going from quarts per minute to gallons per second. We're actually doing two conversions. So I want to show you a way to handle this. First of all, let's write over here 3 quarts, and I'm going to write it this way. I'm going to write 3 quarts for 1 minute. Okay? Now, let's take it one at a time. Let's go first from quarts to gallons. Well, I'm going to need a conversion rate in which I'm going to need, first of all, I need it to end up with gallons, and I need quarts to be on the bottom. Notice that my quart and quarts will cancel out if I do this. Well, how many quarts are in a gallon? Well, there are 4 quarts in 1 gallon. So that's going to be my conversion rate. I end up actually dividing by 4 to get into that, to get it into gallons. And next we'll go from minutes to seconds. Now notice that minutes is on the bottom, and I want seconds on the bottom, and I want the minutes to go away. And so now the question is, how many seconds are there in a minute? Well, there are 60 seconds in 1 minute. And now you see I have my equation. Notice that when I multiply, the quarts will cancel out, the minutes will cancel out, and I'll simply be left with gallons per second. On the top, I have 3 times 1 times 1. On the bottom, I have 1 times 4 times 60. Okay, so we have 3, 4 times 60 over 240. So we have 3 divided by 240. So we have 0.0125 gallons per second. And that's our answer. So 3 quarts per minute is the same as 125 10,000ths gallons per second. This up here can be very helpful, particularly looking at the units to determine exactly the conversion rate you need to make this problem work for you. Next one is a similar thing. Let's start off here with our 50 cents, and I'm going to write 50 cents to 1 hour. Notice we're going to convert cents into dollars and hours into days. So first of all, let's convert cents into dollars. Okay, since I want cents and I want this to be dollars, so I'm going to put my dollars here. And to get rid of the cents, we'll put it in the bottom. How many cents are in a dollar? $1 equals 100 cents. So that's my conversion rate. And now hours to day. Now notice we want the day on the bottom. And to get rid of the hour, we'll put the hour on the top. How many hours are in a day? 24 hours in a day, so it's 24 hours equals 1 day. So notice when I multiply, the cents will cancel out, the hours will cancel out. On my top, I'm going to have 50 times 1 times 24 divided by 1 times 100 times 1, and I'm going to have dollars per day. So if we multiply this out, we have 50 times 24. We have 1,200 divided by 100. So we end up with $12 per day is our answer. Not bad. Next one, we want to go, and this is one of those that always shows up on a test, going from feet per second to miles per hour or vice versa. So let's write it out here. 50 feet per 1 second. Okay? So first of all, we want to change feet to miles. And our first conversion factor, we want the miles on top and the feet on the bottom. Again, the feet will cancel out. And we know that there's 5,280 feet per 1 mile. So that conversion is going to convert feet to miles. And now we want to change the seconds to hours. So I'm going to put the hour on the bottom and put the second on top. Again, when I multiply, the seconds will cancel out. I'll be left with hours. And we know that there are, how many seconds are there in an hour? Well, there's 60 seconds in a minute, and there's 60 minutes in an hour, so it's actually 60 times 60, or 3,600 seconds per 1 hour. All right? So if I multiply through here, I'm going to have, number-wise, I'm going to have 50 times 1 times 3,600. And on the bottom, I'm going to have 1 times 5,280 times 1. Then when I look at my dimensions, the feet cancel out, the seconds cancel out, and I have miles per hour. So let's do a little arithmetic here. 50 times 3,600 is 180,000 miles divided by 5,280 hours. So if we divide that accordingly, we find out that that is 34.090909, or about 34.1 miles per hour. Okay? Next problem. Think about a plan. A college student is considering a subscription to a social networking internet site that advertised it only costs 78 cents per day. What is the cost in membership in dollars per year? Okay, so you notice we're going from 78 cents per 1 day, and we want to end up over here with dollars per year. Well, the first question is, how many conversion factors do we need? Well, that's easy. That's going to be 2. Because first of all, we need to change cents into dollars. So we'll end up with changing this to dollars and getting rid of the cents. And then we're going to need to change days to years. So we'll have the years on the bottom because we want that in the bottom and the days there. That's going to be our 2 sites. And so you know 100 cents is $1, and there are 365 days in 1 year. And so that would be the way we do that. Notice that we just need to watch our dimensions to make sure that when we multiply through here, the cents cancel out, the days cancel out, and we end up with the dollars per year. This problem doesn't actually ask you to find it, but it would be 78 times 365 divided by 100. And I get that to be $284.70 per year. So 78 cents a day ends up being $284.70 per year. The next problem is a word problem and asks us to find which recipe requires the most flour per roll. Now, a key word here is the per. When we say miles per hour, we mean miles divided by hours. Feet per second is feet divided by hour. So in this case, what we're looking for is the amount of flour divided by the number of rolls. And they want to know which one requires the most, the largest rate. So let's take a look at them. Recipe A says 4 rolls and 1 cup. Now it's important that I have set this up right, because it's 1 cup of flour to 4 rolls. And I can simplify that to say that that's going to be 0.25 cups per roll. Okay. Same thing for B. In B's case, we have 24 rolls and 8.5 cups. So I'm going to have 8.5 cups divided by 24 rolls. So 8.5 is going to be 2 times 8 is 16. That's going to be 17 halves divided by 24. If you don't remember how to do that math there, I'll show you over here. If I have 17 halves divided by 24, I'll make that into a fraction as well. And if you remember from elementary school days of dividing fractions, dividing by a fraction is the same as multiplying by the reciprocal. So dividing by 24 is the same as multiplying by 1/24. And now we multiply across and we get 17 over 48. And so if we, now I'll take out my calculator here, 17 divided by 48, and I get that that is about 0.354. So I'm going to put about 0.35 cups per roll. So I'm using more flour per roll, not just total, in recipe B. So let's look at recipe C. So in C we make 45 rolls in 12 cups. So 12 cups on top and 45 rolls. So 12 divided by 45 is 0.267, or about, we'll just say about 0.27 cups per roll. So which one uses the most? B. B uses the most flour per roll. Error analysis. Find the mistake in the conversion at right, explain the mistake, and convert the units correctly. All right, they want to know how many yards is, and they set it up this way. They said 8 yards, and then the conversion factor they used was 3 yards is 1 foot. Well, notice something. It is true that you get 8 times 3 divided by 1, you get 24. But notice what happens if you actually look at the units. You actually end up with yard times yard divided by feet. So you end up with 24 yards squared divided by feet, not 24 feet. Notice how the units didn't go away because you actually had your conversion factor upside down. What you needed to say was, if I have 8 yards and I want to get to feet, I need a conversion factor that changes it into feet and gets rid of my yards. So I'm looking for how many feet are in a yard. There are 3 feet in 1 yard. And so the yards cancel out, and we do end up with 24 feet. And so in this case, the answer is right, even though the conversion that they used was wrong. So in essence, they understood, oh, I get 3 feet per yard. They wrote the wrong conversion factor, but because they set it up, it actually got the right answer. Okay. May want to watch on the homework problem. They may have flipped it around, and you need to flip it back the other way to get the correct answer. Number 10, suppose you want to convert feet to inches. Which unit should be in the numerator, and which unit in the numerator, which unit should be in the denominator? Well, if I'm starting, let's use an example. Suppose I have 12 feet, and I want to know how many inches that is. Well, the key here is when I set up my conversion, because I want to go to inches, I need inches on top. And to get rid of the feet, I need the feet in the bottom. So, which one will be in the numerator? The inches. Which one should be in the denominator? The feet. That will allow me. Then if I come here 12 inches in one foot, I end up with 144 inches. But the answer, you want to have the inches in the numerator and the feet in the denominator. The table below shows some exchange rates on a particular day. If a sweater sells for $29.95 in US dollars, what should its price be in rupees and pounds? Well, in rupees, you see that $1, let me put down here, I have $29.95, and I want to sell it in rubies. Well, in this case, I want to go to rubies, and I want to get rid of the dollars. So in our case here, 39.57 rupees equals $1. So notice how my dollars will cancel out. And so we just simply have to multiply 29.95 times 39.57, and we find out that that's going to equal 1185.1215 rupees. Second, in pounds. Again, 29.95, and we want to know what's the pounds per dollar. Well, $1 equals half a pound. Again, the dollars cancel out, so we're going to multiply 29.95 times 0.5, and that's going to equal 14.975 pounds. That's what they use in England. Problem 5 asks us, it tells us that 5 miles is approximately 8 kilometers. And it asks us to use mental math. So it's not asking us to actually calculate this, to estimate the distance in kilometers to a town that's 50 miles away. Well, the way that I might think about it is, how many 5 miles are there in 50 miles? Well, 50 divided by 5 is 10. So if there are 10 5 miles and every one of them is about 8, then I would say 10 times 8, and my estimation would be about 80 kilometers. That's how I would do that in my head. Reasoning. A carpenter is building an entertainment center. She's calculating the size of the space to leave for the television. She wants to leave about a foot of space on either side of the television. Would measuring the size of the television exactly or estimating the size to the nearest inch be more appropriate? Well, in this case, I would think that estimating would be fine, because you're estimating to the nearest inch. Well, you know, there's 12 inches equals 1 foot. So if she's leaving about a foot and she's estimated the inch, you know, she could be off a little. It could be a little longer than a foot or a little less, but you're not talking a significant amount. So in this case, the answer would be, I think estimating the size to the nearest inch would be the most appropriate. 14. A traveler changed $500 to euros for a trip to Germany, but the trip was canceled. 3 months later, the traveler changed the euros back to dollars. Would you expect him to get $500 back? The answer is no, and the reason for that is the exchange rate, that's the rate between the money, is always changing. I mean, it can stay consistent day to day, but if you're talking about several months, it's bound to have changed. It goes up and down, and you know, sometimes the dollar is worth more and sometimes it's worth less, and so it's always changing. So the answer is no. He probably would not get the same amount back.